Near Cleveland, Mississippi, stands this significant sign of progress, identifying the new Delta Steam Station of the Mississippi Power and Light Company. Here is striking evidence of the growing industrial South and of new electric power to meet that growth. 210,000 kilowatts of power provided by the big M that stands for Mississippi Power and Light. Using water from this artificial lake fed from the nearby Sunflower River, the new station will have the most modern equipment available to serve its customers. And here comes an important piece of that equipment now. Arriving on a drop frame flat car is main power transformer number 2, a General Electric forced oil air-cooled unit rated 135,000 kVA, which will step up generator voltage of 13.8 kV to 115.5 kV. How do you install one of these giants? Well, that's really our story. So let's watch them go to work. Opposite the transformer foundation, the car is jacked and blocked to take weight from the car's springs so that it will remain level during unloading. Large timbers are used to form the cribbing over which the transformer will move to its permanent position atop the concrete footings. With the cribbing in place, we're ready to start jacking the transformer. 50-ton mechanical jacks are placed under the convenient jack bosses. And the job here is to raise the unit slightly above the level of the footings. 2 corners are jacked simultaneously at one end of the unit, and with timbers placed under the base to hold the gain in height, the jacking process is repeated at the other end of the unit. As the transformer moves up, blocks inserted under the jacks provide a higher base for further jacking. Height of the unit is more than 10 inches now, and we're ready to bring in some small steel I-beams. The placing of the beams under the transformer preserves the gain in height and frees the blocking for further use under the jacks and base. With the beams in place, the crew can go ahead and raise the unit the last 6 inches needed to obtain a level above that of the footings. With the proper height attained, larger and longer skid beams are brought in. Originally used to set the generators, these beams will support the transformer on the short trip to its permanent position. The large beams are winched through under the unit and across the wooden cribbing area. Meanwhile, the smaller I-beams are positioned on top of the footings. A mixture of grease and graphite is applied to the skid beams so that friction will be reduced during the movement of the transformer. The transformer itself will actually be moved directly on these long, thin skid plates, which will slide like skis over the greased skid beams. Now then, with the skid plates in position, we're almost ready for the move itself. Cables are placed around the sheaves and attached to pulling eyes at the base of the transformer. Cable number 1 to a crane winch is ready. Cable number 2 to a bulldozer winch is ready. And here she comes, upright and steady, with the crane and bulldozer winching the unit easily across the cribbing toward the footings. The foreman watches every move as the transformer slides along the skid beams, signaling the crane and bulldozer operators to keep the pull steady and even. Let's watch this same move from the side. We've reached this stage of the job at the end of only 1 working day, and since the transformer arrived upright in a one-piece tank, no heavy cranes have been required to tip it up, and no top tank section has to be installed here at the site. Important time and money savers in the installation of any large power transformer. As the big move ends, cables are loosened, and with the transformer off the car, the large skid beams can be removed. And And now the car can be released to the railroad without delay. Before the transformer is lowered and adjusted into final position, cribbing is built at both ends of the footings. This will enable the crew to jack the unit up just enough to free the skid plates and beams, and then lower the unit to its permanent location. With the transformer jacked up for the last time, skid plates are removed, and then the small I-beams. Now the unit is jacked down until only some small adjustment rods lie between the transformer and the footings. The rods are used to permit lateral alignment of the transformer, and after their removal, the transformer is jacked down for the last time. Chisel marks near the top of the tank permit easy centering of the unit on its footings. And there she stands on the foundation in a day and a half and ready for the installation of auxiliary equipment. At Delta Station, work on this part of the job was actually getting underway on main power transformer number 1, even as unit number 2 was being moved to its foundation. Let's watch the installation of accessories on unit number 1, which was placed on its foundation a few days earlier. This starts with a check to determine that all auxiliary equipment is on hand. A packing list shipped in one of the crates helps locate the parts. Following this check, the first of 6 unit coolers that circulate and cool the oil is lifted alongside the transformer and uncrated. After venting the tank to relieve gas pressure, a shipping cover is removed to make ready for the upper shutoff valve to which the first cooler will be mounted. Cleaning the gasket surface assures an oil-tight connection. Oil-proof Gliptol paint is used for retouching the flange except where it will be in contact with the gasket. The upper valves in this case were shipped separately to meet railroad clearances. Gasket surfaces are rubbed clean before the valve is raised and bolted to the flange. The lower shutoff valve is shipped on the transformer, and here again the gasket surfaces are cleaned with denatured alcohol and the flange retouched if necessary. The bottom of the cooler will be secured to the lower shutoff valve by a connecting elbow. All gaskets used for shipment are made of nitrile rubber and thus have the advantage of being reusable for final assembly. Any blocking to be removed after shipment is marked by a red X. This block prevents damage to the cooler fan mounts during transit. In order to check the direction of fan and pump rotation of each cooler, a temporary 440-volt line is brought in and connected to the power supply terminals in the control housing at the bottom of the unit cooler. With the cooler raised so that the pump impeller is visible from the rear, the control power switch is turned on and off quickly while pump and fan rotation are checked. Now then, after the connecting elbow is bolted to the bottom of the cooler, the connection to the upper valve is made directly from the pump housing, and the cooler is now bolted both to top and bottom tank flanges. Oil filling of the transformer is done under vacuum to keep the insulation free of air and moisture. This vacuum pump will exhaust the carbon dioxide shipping gas and remove air from the oil as it sprays into the tank from the top. A pipe-threaded opening in the cover accommodates a valve for the vacuum line. And with the valve in place, the vacuum hose is hoisted to the top of the transformer and connected. Then, after the cooler valves have been opened, the vacuum pump is operated for 4 hours prior to filling, during filling, and for 4 hours after filling. Transformer oil brought in by tank car on the Delta Station siding serves as both insulator and coolant and must meet rigid specifications. A small amount of oil is allowed to run out of the tank car through a coupling and valve installed at the site, and a sample is taken for testing. Voltage is increased at the rate of 3 kV per second until breakdown occurs, and with a dielectric strength of better than 22 kV determined we're ready for the filter press. Filtration of the oil prevents impurities and moisture from being pumped into the transformer. Had it tested lower than 22 kV, several passes through the press would be made to improve the oil before pumping it into the transformer. Metal piping or oil-proof synthetic rubber hose is preferred for handling the oil. Then, with hot, oven-dried filter paper inserted in the press, we're ready to start pumping. A bypass valve is opened, the pump started, and a small quantity of oil is drained off to flush the system. Once this is done, oil filling under vacuum goes ahead. During the filling, we can proceed with other phases of the installation. For instance, there's the job of connecting the pre-wired control devices on the unit coolers to the conduit on the transformer. Also, winding and oil temperature equipments must be installed. And baffles mounted. The baffles assure that all fans get a continual supply of fresh, cool air. Now, with the liquid at the top of the core, we are ready for an inspection of the interior. A General Electric field engineer using a flashlight makes a thorough check to see that internal parts have not moved or shaken loose during shipment. To prepare for the next step, the installation of bushings, the high voltage leads are brought out and the protective tape used for shipment is removed. Each bushing is mounted to the tank by one of these adapters that is bolted in place with the same nitrile gasket used for shipment. The bushings themselves, after removal from the shipping crates, are cleaned and then carefully raised to the transformer. Special lifting eyes on the bushings are provided for the lifting cables. Once the bushing is ready to be set down, a small wire is used to draw the cable through the bushing tube. And the bushing is then lowered slowly into the adapter. The bushing is bolted progressively in one direction until all bolts are uniformly tight. The high voltage lead is secured by a small pin, after which the bushing terminal cap is added. A potential device is used to operate relays, voltmeters, and other instruments with a capacitance tap on the high voltage bushing providing the necessary power. With this job done, we are ready now to install the low voltage bushings. The procedure here is much the same as for the high voltage bushings, with the crane guiding them carefully into place. The wooden blocks protect the porcelain from possible damage by the cables. Internal connections to the low voltage bushings are made through manholes in the side of the transformer tank. The rectangular plate to which the low voltage bushings are bolted is made of non-magnetic steel to prevent overheating of the cover by the intense field around the high current bushings. With all tank openings sealed, the automatic gas seal oil preservation system is initiated by turning on the cover valves in the gas line. And then the gas valve in the control cabinet. With the auxiliary equipment installed, an inspection party looks over the job. Here is 135,000 kVA of power in place, only 6 1/2 working days after arrival at the site. Now then, let's travel more than 1,000 miles to the north, where somewhat different installation methods are used on another modern power transformer. This time we're at the new Oak Creek station of the Wisconsin Electric Power Company. Located on the shore of Lake Michigan, only a few miles south of Milwaukee. Designed to be one of the most efficient plants ever built, This station incorporates the latest techniques and equipments. Let's look briefly to see how modern methods and modern power transformers save valuable installation time. At Oak Creek, solid concrete pads outside the turbine room will accommodate the transformers. Coming in on the siding is a General Electric forced oil water-cooled transformer rated 145,000 kVA. It should be remembered, of course, that installation methods may vary somewhat from those used here and at Delta Station. But in every case, handling of the units is made easier because they have been shipped upright in a one-piece tank. Let's look at some of the highlights. With the car opposite the concrete pad, we can remove the blocking and proceed to take some of the weight from the springs. The jacks used in this case are of the hydraulic type, a little slower, but requiring less effort than the mechanical types. After the driving of wedges, jacking of the transformer itself is begun, and turnbuckles secured to the car are loosened as the transformer moves up. While the unit is being raised to a height slightly above that of the concrete pad, large timbers are brought in to form the cribbing over which the transformer will move. And again, a carefully laid out crisscross pattern of supports is used. At Oak Creek, however, large wooden rollers rather than steel skid beams are used to move the transformer to the pad. The angle bracing between the transformer and the wood beam runners is added to provide additional support during the move across the cribbing. A truck with winch stands on each side of the transformer, ready to draw cables that are fastened to pulling eyes at the transformer base through pulley blocks anchored to the building. And with a slow and steady pull of the cables, we're rolling. 110 tons of power transformer moving on an even keel towards the foundation. With the rail siding close to the pad, the move is a short one. And again, the time and handling involved in the move are less because the transformer arrived in an upright position. With the unit in almost final position on the pad, the excess cribbing is removed and the drop frame car freed on schedule. Then it's a relatively simple matter to jack up the transformer just enough to remove the rollers and the runners. The hydraulic jacks let the unit down to a height just sufficient to accommodate small rods, which, as in the Delta Station job, are used to shift the unit slightly for final positioning. To accomplish this, the jacks are used horizontally. With the moving job done, power company officials inspect job progress. And the contractor starts installing the auxiliary equipment. Brackets for the oil conservator are fastened in place as a first step in preparing the transformer for oil filling. The conservator preserves the insulating and cooling properties of the oil and keeps impurities out. The relief pipe installed next provides protection from possible excessive pressures. At Oak Creek, too, a vacuum is maintained before, during, and after the oil filling operation. A truck crane is used now to move the oil car into position, and after an oil sample is tested, the connection is made to the oil car, the oil line is secured to the filter press, and the press itself is made ready for operation. With the hose raised and attached, the oil filling can proceed. At the Oak Creek station, the low-voltage bushings are installed first. These GE high-current bushings, rated 7,000 amperes, eliminate the need for more than one low-voltage bushing per phase. Now, let's get the high-voltage bushings into place. The high side of the transformer, by the way, will deliver 132 kV from generator voltage of 13.8 kV. A guide wire is again used to help pull the high voltage lead up and through the center tube of the high voltage bushing. With the bushings in place, there remains but the job of mounting and assembling the lightning arresters and the remotely located water coolers. the final steps in installing 145,000 kVA of modern power transformer. But actually, the story of new power plants and new improved equipment is always an unfinished one. For example, only a few months after these scenes at the Delta Station and the Oak Creek Station were recorded, the New Haven Railroad delivered this new drop-frame flat car. Built along specifications of General Electric engineers, this car is a significant step forward in permitting transformers rated as high as 500,000 kVA to be built and shipped upright in a one-piece tank. With a capacity of 400,000 pounds, the new car advances shipping weight by 60,000 pounds over previous limits. And here outside General Electric's Pittsfield, Massachusetts plant is still another advance in modern power transformer design. With all accessories aboard a single car, this new 120,000 kVA transformer is designed with its unit coolers already mounted in position on each end of the tank, permitting a full day's saving in installation time at the power plant. As the new unit moves out of the yard, destined for the Public Service Company of Indiana, General Electric is already working on the power transformer advances of tomorrow. Advances which, like those of the electric utility industry, mean new power in place, installed faster and easier than ever before.